Hello everyone. So in this lecture we will see utility of standard deviation, variance and coefficient of variance. So we have this managerial problem in which we have two stock prices. First is of Zomato and second is of IRCTC for last 6 months in 2022. And we need to find this first one, apply suitable technique to find variance and standard deviation for each firm stock price, and second question is apply your understanding to identify the firm whose stock price had the greater relative dispersion and with high risk. So this concept, there are two things. First is standard deviation, variance, and second is utility of standard deviation and variance. Okay, so we have these two columns. First is Zomato and second is IRCTC, and in first part you need to find variance and standard deviation. So standard deviation is denoted by sigma and variance is denoted by sigma square. So first you need to find sigma, then you will find sigma square, and there are two individual data. We can consider this as X series, this as Y series. So two individual data are there. So we will consider these two independent individual data and we will find their standard deviation. So for individual type of data, we have two methods. First is direct method and second is shortcut method. So we will apply shortcut method because this is very less time consuming and this is 99% correct answer. So we will apply this formula to find standard deviation and variance. So this formula for standard deviation of X and second formula for standard deviation of Y. So I can write this first formula. This first formula as sigma X and this as sigma Y. That's why we can write this as sigma dx, summation dx square, and this is summation dx, and this is summation dy and summation dy. So we will prepare two columns. First is for Zomato and second is for IRCTC. In same way for second part you need X bar and Y bar also. So X bar equals to A plus summation dx upon n for first data set, and for second data set this is B is assuming for Y series, this is summation dy upon n. And for second part we will find coefficient of variance CV of first CBX and second is what CVY, coefficient of variance of second. In second part apply your understanding to identify the firm whose stock prices had greater relative dispersion. Greater relative dispersion means greater variance, and if the variance is high then risk is also high. So in these two values, if the coefficient of variance of X is higher than CVY, so this first is comparatively more risky. This means Zomato will be more risky. So first we need to find this sigma X, sigma Y, X bar, Y bar. So we will prepare two tables. First is this is for Zomato and second is for IRCTC. And for first data set, first we will find dx is equal to x minus a, and for second dy is equal to y minus b. Now value of x and a and b is what? In this x column you may take any value, but we will take approximately middle. Middle means highest plus lowest divided by 2 near about. So we are taking this as a in first data set, and in this second data set we are considering this 730 as b. So you can find 64 minus 65 is equal to minus 1, that is what dx, and then second column you will prepare for dx square, and after that this is what? This is the summation of dx square. This is the summation of dx square, and this is what? This is the summation of dx. And for second, this 730 is b, so 712 minus 730 is, that is what? Minus 18. In the same way, you can find this whole the column, and this summation is considered as what? Summation dy, and this is the square. This is the square of this dy. So this is dy square, and summation of this is considered as what? Summation dy square. So you will have all these values. Now you will put in these two formulae. So you will see this first dx, summation dx is 6 minus 1, and dx square is 651. So we will put 651 here, and number of observations are 6 minus summation dx square is 1, and this divided by 6, and then we will find its under root. Then you will get standard deviation. So for this case, standard deviation sigma x is 10.41, and for variance you can find its square, sigma square. This become what? Variance. So square of this 10.41 is considered as variance. So the second part, we can write variance also. So sigma square means variance is square of this 10.41, and this is equals to 108.36. And second is sigma y. In sigma y, we will put all these values from this table. So this is minus 1, and you will put now values in this. So this is under root, and summation d square is what? Summation d square is 14969. So this is 14969, and this quantity divided by 6 minus 1 divided by 6, and then square. Then you will see this sigma y equals to this is 49.94, and for variance of this is what? This is sigma x square, this is sigma y square. So square of this you will get as 2494. Now for arithmetic mean, you will put value here. So a equals to, we have taken 65, and summation dx for this data set is 1. So you will get x bar equals to 64.83. And for coefficient of variance is sigma x upon x bar into 100%. So you will see sigma x is 10.49, just we have calculated, and x bar equals to this is 64.83, and this multiplied by 100%. So you will see this quantity as 16.05%. So this is 16.05%, and for second data y bar is equal to b is what? 730, and summation dy for this data set is 1. So this is 731 upon 6, that is what? That is 730.16, and then coefficient of CB for y is sigma y upon y bar multiplied by 100%. So this become what? Sigma y is 49.94, and this quantity y bar divided by 730.16, and this quantity multiplied by 100%. So you will see this as 6.83%. So in these two Zomato and IRCTC, first coefficient of variation for Zomato, this is 16.05, and second is for IRCTC. So we can say coefficient of variation for X means Zomato is greater than coefficient of variation for IRCTC. So this means this is with high risk, with higher dispersion. greater dispersion, and greater dispersion implies high risk. So this first share of Zomato is with high risk. So I hope you understand this concept. So please like this video and subscribe my channel Ganit Coach. Have a nice day. Thank you.